Good afternoon. My name is Jim Musselman. I'm with the National Center for Asphalt Technology, and I'm going to talk to you a little bit today about a project that we did over the last couple years with the Federal Aviation Administration that was titled the In-Service Performance of Airport Flexible Pavements Constructed Following State Specifications for Highway Materials. Really kind of rolls off your tongue. But thought it was an interesting project. It originated back in 2018, you could say. There was a bill passed by Congress which required the FAA to allow the use of state highway materials specifications for certain airfield construction, provided the aircraft do not exceed 60,000 pounds gross weight. If it's requested by the state, if safety is not negatively impacted, or if the life of the pavement will not be shorter than if they're constructed using FAA specifications. So that's kind of the important thing. Remember that third bullet there. The other thing is to keep in mind that even though this is a recent legislation that was passed by Congress, the FAA has actually permitted the use of highway specs for airport construction, again, under certain conditions since 1977. Some of the background on this, as you would expect, there's, between highways and, say, runways or even taxiways, there's significant differences in the loading conditions between the loads, the total loads, tire pressures, and the types of loading. They're significantly different. And highway specs weren't necessarily developed to accommodate the types of loads and the conditions that airports face. So the FAA started this project to basically evaluate the performance of airports that had been previously built using highway specifications and compare those to pavements that were constructed over the same time period, essentially, using the traditional FAA specs, the P401 specs. Some of the methodology that we used, it was a little bit complicated, and we won't bore you with all the details, but ultimately we used pavement management reports that were provided by a consulting firm, Applied Pavement Technology, or AP Tech, and they have various contracts with a number of airports across the U.S. To conduct their pavement inspections that they have to do. I think they do them roughly every 2 or 3 years. So we had access to that data. The other problem that we ran into was trying to find enough projects where we could get actual construction data in addition to performance data. That was part of the project, was to review the construction records. And generally what we found was that was primarily in the Great Lakes region for the FAA where we found that. And the construction records then were provided by the DOT's divisions of aeronautics or aviation, and also we got some by AP. As I mentioned, there were a number of challenges associated with coming up with the number of construction records that we needed, as well as performance data. And we thought, gosh, if we try to do this at different regions around the United States, I think originally the FAA wanted us to evaluate 30 projects. We'd end up having maybe 1 or 2 projects per region, and it just didn't seem like there was enough. So what we kind of felt like was if we used projects that primarily came from one region, that would give us enough data to reasonably draw some conclusions from. So the projects that we got were basically Illinois, Indiana, Michigan, and Wisconsin. And in addition, we'd already acquired some data from a couple airport projects in Georgia, so we went ahead and threw those in as well. Some other things when we were working on the project selection. First, we excluded any projects that were built prior to 2003. Part of that was, think about when SuperPave was first adopted around the United States. It was generally most highway agencies were doing that somewhere in the mid to late 90s to early 2000s. And so again, we wanted to make sure that we got more recent construction and mixed design methodologies. The other thing that we did is we excluded projects built after 2018. They were just too new. We just didn't want to have a bunch of projects that were in great shape because they're, 2 years old. As far as pavement type, the original plan included all sorts of pavement types: runways, taxiways, aprons, and shoulders. However, the available data, while we did get some taxiways, aprons, and I'm not so sure about shoulders, but the available data that we had shifted our focus to primarily runways. So ultimately, we came up with 40 projects over 5 states. You can see the little graphic, and it shows you 19 of the projects used state specifications, and 21 of the projects used FAA specs. We would compile these project summaries. We would have information about the airport, summary of what type of construction went on, summary of the various aircraft operations, the maximum gross weight bearing capacity of the runway, and then we'd also probably most importantly, compile the PCI data. So this is a kind of a master list of the total projects that we had, and you can see they're color coded. So the first one up towards the top, they're from Georgia. You can see most of the Georgia ones. If you can see my cursor a little bit, you could see there were some FAA, some state, but then we had Illinois, which was all state specs, Wisconsin, state specs. Indiana was FAA specs. Michigan state specs, and then Wisconsin was primarily FAA specs. I think they had one or two state specifications thrown in there as well. This is an example of the pavement condition index data that we would get for these projects. Now, this is from a project in Waukegan, believe that's Wisconsin. I'm a Southern guy, so bear with me. But anyway, it shows the particular, in this case, this is a joint reflective crack. It gives a number, represents that. It's low severity. They measured 625 feet. They come up with a density based on the size of the section, and then they get a deduct. And then what they do, they've got a way of kind of combining these to give you a numerical deduct. They don't just add them up together or take the average. It's a little more convoluted than that. But you could see here it had joint reflective cracking. It had LNT cracking, which is longitudinal and transverse cracking. And then it had weathering. So these are sections 1 and 2 for runway 14-32 from this one airport. The other thing I want to point out is, in this case, for this section, the percentage of the distress deducts, these were 100% related to climate. These were climate-related distresses. Same thing here. Even though swelling kind of falls, and we'll talk about these categories later, there really wasn't enough. It didn't move the needle. So it ended up being rounding to 0 on the amount of swelling. But again, 100% climate. So just wanted to point that out because we're going to come back to these numbers later on. So this is a master list of all the different projects, and you can't read it, and I don't expect you to. But so if we zoom in a little bit, we'll look at, there's Waukegan again in Illinois. I was close. I named 2 states, and it was the other one. So here's the example if you zoomed in on that. So this shows, it was our project number 9. It was in Illinois, the Waukegan National Airport. They repaired and overlaid runway 1432. It was done in 2011. They used state specifications. These are the different sections. One thing to note is we use the average because we might have some runways with only one section, and Waukegan has whatever that is, 7. We didn't want them to have too much of an overweighting, so we would take the average. So again, at year 0, it's got a score of 100. The PCI ratings go on a scale from 0 to 100. 100 is perfect. 0 is, basically a concrete pavement, okay? So you've got, it starts at 100 at year 1. It dropped to a 93.7. I think this is year 5. Drops to an 81.1. Year 7, 65.6. So you can see it's trending in a southern direction. And again, we would plot this for each of the particular runways. So you would almost get a graphical feel for how that particular runway was performing. In addition to that, part of the project that we worked on was reviewing the specifications, just to kind of see what did they involve. And we used basically the P401 specs for asphalt pavements from the FAA as kind of the baseline. But the states that we looked at were from Georgia, Illinois, Indiana, Michigan, and Wisconsin. A couple things I want to point out here. One, This is the Georgia DOT specs. These are their normal highway specs. Illinois, notice this, standard specifications for construction of airports. So the Illinois DOT, they actually have their own airport specifications. Indiana, they use their standard specifications. Michigan, also the specs came from their airports division. And then same thing with Wisconsin. So 3 states actually had their own aviation specifications, which were kind of a hybrid between P401 and their highway specs. I would say they're probably closer to their highway specs than they were the P401 specs. It's almost like they kind of went down the specification cafeteria line, and they would pick and choose basically what do they like about this spec and what they don't like. So if there was an aggregate requirement they didn't want to apply in their state, they wouldn't include it, that kind of stuff. When we did the specification reviews, this is what we'd focus on, were the aggregate requirements, binder, mixed design, quality control, acceptance, and construction. The one thing, we won't really talk about it anymore, but binder, I know that, for example, P401 specs gives pretty detailed description on how you select the particular grade of binder, and that can always be a real challenge for designers. But typically most of the highway specs or the DOT specs didn't necessarily include that. So these are some of our findings. So what we did is the PCI ratings for each of the projects that were compiled and summarized based on the types of specs that were used. And the 2 categories were your FAA versus state highway. And then a plot of that data was made of the PCI ratings by age, similar to what I showed you previously. So again, the graph on the left, these are all the FAA projects. The ones on the right, those are all the ones that you'd state specifications, okay? So you kind of get a feel. So on the y-axis is the PCI rating. Starts at 0, which is, a terrible concrete pavement, goes up to 100, which is a perfect asphalt pavement, okay? And all the way down. You can see both of these, they seem to tail out. They're right around, coming in somewhere around at year 14, you get to a 60. Here at a PCI rating, a year 60, it's about a 14 or a 15. Go back a slide or two to get to a 55. You're probably looking at about 15, 16 years for both categories of projects. And then we also did an analysis of variance, and that indicated that the effect of the specification type was not statistically significant. So that kind of indicates the specs were equivalent. So the other thing, like I mentioned, was we looked at the distresses, and the distresses were categorized, they are categorized based on load-related distresses. You could see alligator cracking, corrugations, rutting and shoving, those are related to load. Climate-related would be block cracking, joint reflective cracking, longitudinal and transverse cracking. They don't break those out. That's one master category. So you could have a project with 100% longitudinal cracking and another project with 100% transverse cracking. They would show up as both 100% L&T cracking, okay? They don't differentiate. Raveling and weathering are also climate. And then there's the other distresses, which is bleeding, depression, jet blast, erosion, oil spillage, polishing. You can read the slide as well as I can read it to you. So there's 3 different categories, okay? And so again, what we did, and remember that one chart, we then took these projects and kind of looked at them in terms of where do we see the most of the distress deducts. And if you look at this, now these are for the FAA specs. You could see here that majority of it is climate related. A little bit over here in at Anderson Airport, they had about 15% load related. Same thing in other airport, a small percentage, but the bulk of everything is climate related. Now let's switch over. Now we're looking at the state specification projects. Kind of the same thing. The bulk of the distresses are climate related. It'd be interesting to see this type of data for highways because you'd probably see exactly the same trends. that the bulk of the distress are climate related and it's some type of cracking. Okay. So again, for both types of specs, climate related distresses were the predominant mode of distress, and that's almost exclusively longitudinal and transverse cracking. There was some weathering. Weathering is just almost kind of like maybe a little teeny bit of raveling of the fines that come out, and the surface just looks older. That's weathering. Load-related distresses were relatively minor. 3 of the 21 FAA projects had load-related distresses. 5 of the 19 state projects did, and of those 8, one of them was medium severity alligator cracking. 5 of them were low severity alligator cracking, and 2 of them were low severity rutting. So some of the conclusions we came up with was based on the PCI ratings. The performance of airport asphalt pavements constructed using state highway specifications is statistically equivalent to pavements constructed using the FAA specs. But it's important to note that 3 of the 5 states, they actually had their own aviation specifications. And the other big bullet to kind of point out is that the climate-based distresses were the predominant mode of distress for both types of projects. And that was almost exclusively longitudinal and transverse cracking and weathering being the most prevalent. And some of that, keep in mind, if you have a longitudinal joint that just with time they they pull open and you get a little crack in the joint, that's a longitudinal crack. Doesn't have to be in the wheel path, doesn't have to be between the wheel path. If it's in the joint and there's a crack, it counts as a crack. Some of the other things, the number of load-related distresses were relatively low, only 8 of 40 projects, and 5 of those used state specifications and 3 used FAA specs. Of the 6 projects that had alligator cracking, 5 of them use state specs, which could be an indicator that maybe the state specification mixes may have reduced fatigue resistance. I didn't go into it much. I think I will in the next slide or two, but I think the FAA does some things in their mix design requirements that gets a little bit more binder in the mixes, which could make them a little bit more fatigue resistant. But again, not too many of the projects. 6 projects, that does not, it's hard to make a definitive conclusion on that. Rutting was observed on only 2 of the projects, and they both used FAA specs. And again, 2 projects, you can't really make any conclusions one way or another. As I mentioned on the previous slide, the current FAA mix design specification requirements generally should result in slightly higher effective binder contents. I think the FAA requires a slightly higher VMA, and I think they also design at slightly lower air void contents. Of course, I know sometimes it's challenging. They also have gradation limits. So it's tough sometimes to meet the VMA requirements and also meet the gradation requirements that they have. In general, the FAA density spec is a good bit more robust than most of the state specifications. If you recall, well, the current FAA specs, they require you to cut back the joint if it's, if the pavement's been down for more than 4 hours. In most cases, it will have been. And the majority of state specifications that we looked at did not include a joint density requirement. So that's kind of a big deal. The other thing is, as I mentioned several times, these were not necessarily all true highway specs. Of the 5 states that we looked at, 3 of them had separate aviation specs that were used for airport construction. And as I mentioned, they were kind of a hybrid between the FAA and the state specs. So what were the recommendations that came out of this study was, well, the data basically supports the continued use of the state highway specs for asphalt pavements at airports that serve aircraft that don't exceed 60,000 pounds if it's requested by the state. We also recommended that maybe FAA put together some guidance for airports that are using state specs regarding the construction and acceptance of longitudinal joints. It just seemed like, it is important as prevention of FOD on an airport is you certainly want to make sure you get good joints. Those joints will deteriorate and start to ravel, and that can create a big problem. Also, based on the amount of climate-related distresses, it's certainly worth looking into, and I think FAA is on coming up with a suitable mixture cracking and durability tests that can be done, during the mix design process or even for acceptance. And I know there's a number of tests that are being looked at today. So hopefully one of those will pan out. And I'd like to acknowledge the FAA they sponsored the project and they were great to work with, as well as the FAA, some of the regional divisions. They were helpful in helping us find projects. So with that, this is my name and contact information. I know I'm not with you today. I hope weather's good in Colorado. I work for NCAT at Auburn University in Auburn, Alabama, but I'm a remote employee and I work in Gainesville, Florida. So feel free to either give me a call, there's my telephone number, or shoot me an email, and I'll be glad to answer any questions you have. The final report that we published on this is with the FAA, and they expect it to be published and made available sometime probably within the next month. And with that, that's all I've got for you. Thank you very much.